Physicists are made of atoms. A physicist is an attempt by an atom to understand itself. Michio Kaku, Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos. The mind of God, which Einstein wrote eloquently about, is cosmic music resonating throughout hyperspace. Nobel laureate Steven Weinberg likens this multiple universe theory to radio. All around you, there are hundreds of different radio waves being broadcast from distant stations. At any given instant, your ICE or car or living room is full of these radio waves. However, if you turn on a radio, you can listen to only one frequency at a time. These other frequencies have decohered and are no longer in phase with each other. Each station has a different energy, a different frequency. As a result, your radio can only be turned to one broadcast at a time. Likewise, in our universe we are tuned into the frequency that corresponds to physical reality. But there are an infinite number of parallel realities coexisting with us in the same room, although we cannot tune into them. Although these worlds are very much alike, each has a different energy. And because each world consists of trillions upon trillions of atoms, this means that the energy difference can be quite large. Since the frequency of these waves is proportional to their energy, by Planck's law, this means that the waves of each world vibrate at different frequencies and cannot interact anymore. For all intents and purposes, the waves of these various worlds do not interact or influence each other. The laws of physics, carefully constructed after thousands of years of experimentation, are nothing but the laws of harmony one can write down for strings and membranes. The laws of chemistry are the melodies that one can play on these strings. The universe is a symphony of strings. And the mind of God, which Einstein wrote eloquently about, is cosmic music resonating throughout hyperspace. The poet only asks to get his head into the heavens. It is the logician who seeks to get the heavens into his head. And it is his head that splits. G.K. Chesterton. Our sun is not Earth's true mother. Although many peoples of Earth have worshipped the sun as a god that gave birth to Earth, this is only partially correct. Although Earth was originally created from the sun, as part of the ecliptic plane of debris and dust that circulated around the sun April 5 billion years ago, our sun is barely hot enough to fuse hydrogen to helium. This means that our true mother sun was actually an unnamed star or collection of stars that died billions of years ago in a supernova, which then seeded nearby nebulae with the higher elements beyond iron that make up our body. Literally, our bodies are made of stardust, from stars that died billions of years ago. Indeed, Isaac Newton himself, who introduced the concept of immutable laws which guided the planets and stars without divine intervention, believed that the elegance of these laws pointed to the existence of God. Physicists often quote from T.H. White's epic novel The Once and Future King, where a society of ants declares, everything not forbidden is compulsory. In other words, if there isn't a basic principle of physics forbidding time travel, then time travel is necessarily a physical possibility. The reason for this is the uncertainty principle. Unless something is forbidden, quantum effects and fluctuations will eventually make it possible if we wait long enough. Thus, unless there is a law forbidding it, it will eventually occur. These parallel universes are not ghost worlds with an ephemeral existence. Within each universe, we have the appearance of solid objects and concrete events as real and as objective as any. The quantum theory is based on the idea that there is a probability that all possible events, no matter how fantastic or silly, might occur. Consciousness determines existence. The mind reels when we realize that, according to this interpretation of quantum mechanics, all possible worlds coexist with us. Although wormholes might be necessary to reach such alternate worlds, these quantum realities exist in the very same room that we live in. They coexist with us wherever we go. Whether we like it or not, if we are to pursue a career in science, eventually we have to learn the language of nature, mathematics. Without mathematics, we can only be passive observers to the dance of nature rather than active participants. As Einstein once said, pure mathematics is, in its way, the poetry of logical ideas. Let me offer an analogy. One may love French civilization and literature, but to truly understand the French mind, one must learn the French language and how to conjugate French verbs. The same is true of science and mathematics. Galileo once wrote, "The universe cannot be read until we have learned the language and become familiar with the characters in which it is written." It is written in mathematical language, and the letters are triangles, circles, and other geometrical figures, without which means it is humanly impossible to understand a single word. Cosmology is the study of the universe as a whole, including its birth and perhaps its ultimate fate. But if electrons can exist in parallel states hovering between existence and non-existence, then why can't the universe? After all, at one point the universe was smaller than an electron. Once we introduce the possibility of applying the quantum principle to the universe, we are forced to consider parallel universes. At first, it seems as if the existence of complex life forms on Earth violates the second law. It seems remarkable that out of the chaos of the early Earth emerged an incredible diversity of intricate life forms, even harboring intelligence and consciousness, lowering the amount of entropy. Some have taken this miracle to imply the hand of a benevolent creator. But remember that life is driven by the natural laws of evolution, and that total entropy still increases, because additional energy fueling life is constantly being added by the sun. If we include the sun and earth, then the total entropy still increases. Before an observation is made, an object exists in all possible states simultaneously. To determine which state the object is in, we have to make an observation, which collapses the wave function, and the object goes into a definite state. The act of observation destroys the wave function, and the object now assumes. For any reasonable value of omega at the beginning of time, Einstein's equations show that it should almost be zero today. For omega to be so close to 1 so many billions of years after the Big Bang would require a miracle. This is what is called in cosmology the fine-tuning problem. God, or some creator, had to choose the value of omega to within fantastic accuracy for omega to be about 0.1 today. For omega to be between 0.1 and 10 today, it means that omega had to be 1.00000000000000001 second after the Big Bang. In other words, at the beginning of time the value of omega had to be chosen to equal the number 1 to within 1 part in 100 trillion, which is difficult to comprehend. My own emotional feeling is that life has a purpose ultimately. I'd guess that the purpose it has is the purpose that we've given it and not a purpose that came out of any cosmic design. If we were to pluck this string, the vibration would change, the electron might turn into a neutrino. Pluck it again and it might turn into a quark. In fact, if you plucked it hard enough, it could turn into any of the known subatomic particles. Strings can interact by splitting and rejoining, thus creating the interactions we see among electrons and protons in atoms. In this way, through string theory, we can reproduce all the laws of atomic and nuclear physics. The melodies that can be written on strings correspond to the laws of chemistry. The universe can now be viewed as a vast symphony of strings. My feeling is that in religion there are very serious things, like the existence of God and the brotherhood of man. That are serious truths that we will one day learn to appreciate in perhaps a different language on a different scale. So I think there are real truths there, and in the sense the majesty of the universe is meaningful, and we do owe honor and awe to its creator. Inflation is continuous and eternal, with big bangs happening all the time, with universes sprouting from other universes. In this picture, universes can bud off into other universes, creating a multiverse. In this theory, spontaneous breaking may occur anywhere within our universe, allowing an entire universe to bud off our universe. It also means that our own universe might have buddied from a previous universe. In the chaotic inflationary model, the multiverse is eternal, even if individual universes are not. Some universes may have a very large omega, in which case they immediately vanish into a big crunch after their Big Bang. Some universes only have a tiny omega and expand forever. Eventually, the multiverse becomes dominated by those universes that inflate by a huge amount. In retrospect, the idea of parallel universes is forced upon us. First is epsilon, which equals 0.007, which is the relative amount of hydrogen that converts to helium via fusion in the Big Bang. In other words, the process of observation determines the final state of the electron. Margaret Geller, a professor at Harvard University, said, "I guess my view of life is that you live your life and it's short. The thing is to have as rich an experience as you possibly can. That's what I'm trying to do. I'm trying to do something creative. I try to educate people." Although we take this for granted, the cancellation of positive and negative charges is quite remarkable, and has been experimentally checked to 1 part in 1021. Of course, there are local imbalances between the charges, and that's why we have lightning bolts. But the total number of charges, even for thunderstorms, adds up to 0. If there were just 0.00001% difference in the net positive and negative electrical charges within your body, you would be ripped to shreds instantly, with your body parts thrown into outer space by the electrical force. But if I make an observation, what is to determine which state I am in? This means that someone else has to observe me to collapse my wave function. Michio Kaku, Einstein's Cosmos: How Albert Einstein's vision transformed our understanding of space and time. On average, animals that eat 30% fewer calories live 30% longer. This has been amply demonstrated with yeast cells, worms, insects, mice, and rats, dogs and cats, and now primates. In fact, it is the only method that is universally accepted by scientists to alter the lifespan of all animals that have been tested so far. Michio Kaku, The Future of Humanity, Terraforming Mars, Interstellar Travel, Immortality, and Our Destiny Beyond Earth. Michio Kaku, Hyperspace, A Scientific Odyssey Through Parallel Universes, Time Warps, and the 10th Dimension. Tachyons travel faster than light and have imaginary mass. It's not clear if they fall up or down under gravity. They, too, have not been found in the laboratory. Michio Kaku, Physics of the Impossible, A Scientific Exploration of the World of Phasors, Force Fields, Teleportation, and Time Travel. Michio Kaku, The Future of the Mind, The Scientific Quest to Understand, Enhance, and Empower the Mind. Clearly, invisibility is a property that arises at the atomic level, via Maxwell's equations, and hence would be exceedingly difficult, if not impossible, to duplicate using ordinary means. To make Harry Potter invisible, one would have to liquefy him, boil him to create steam, crystallize him, eat him again, and then cool him, all of which would be quite difficult to accomplish, even for a wizard. Michio Kaku, Physics of the Impossible. O degree USO plus or minus U, O superscript 300 USU UVU. Negative energy may seem like the holy grail to a physicist building a starship, but for a nanotechnologist, the Casimir force is so strong at the atomic level that it becomes a nuisance. The Higgs boson, physicists believe, originally started out as a tachyon. In the false vacuum, none of the subatomic particles had any mass. But its presence destabilized the vacuum, and the universe made a transition to a new vacuum, in which the Higgs boson turned into an ordinary particle. In conclusion, negative energy does exist, and if enough negative energy could somehow be collected, we could, in principle, create a wormhole machine or a warp drive engine, fulfilling some of the wildest fantasies of science fiction. Tachyons at first seemed to violate causality, but physicists believe that their true purpose was to set off the Big Bang, and hence they are not observable anymore. 3 of the 4 forces, excluding gravity, are therefore united by quantum theory, giving us unification without geometry, which appears to contradict the theme of this book and everything we have considered so far. When we force a smile, we activate facial muscles with our prefrontal cortex. But when we smile because we are in a good mood, our nerves are controlled by our limbic system, which activates a slightly different set of muscles. Our brains can tell the subtle difference between the two, which was beneficial for our evolution. Michio Kaku, The Future of the Mind, the scientific quest to understand, enhance, and empower the mind. Another clue to the cause of aging might be telomerase, which helps to regulate our biological clock. Every time a cell divides, the tips of the chromosomes, called telomeres, get a bit shorter. Eventually, after approximately 50 to 60 divisions, the telomeres become so short that they disappear and the chromosome begins to fall apart, so the cell enters a state of senescence and no longer functions correctly. Thus there is a limit to how many times a cell can divide, called the Hayflick limit. When bathed in telomerase, skin cells divide indefinitely, far beyond the Hayflick limit. But it should be pointed out that telomerase has to be regulated very carefully, because cancer cells are also immortal and they use telomerase to attain that immortality. Imagine fish swimming in a shallow pond. They might never suspect the presence of a third dimension, because their eyes point to the side, and they can only swim forward and backward, left and right. A third dimension to them might appear impossible. But then imagine it rains on the pond. Although they cannot see the third dimension, they can clearly see the shadows of the ripples on the surface of the pond. In the same way, Kaluza's theory explained the light as ripples traveling on the 5th dimension. A careful analysis of the DNA within the mitochondria indicates that errors are indeed concentrated here. The hope is that one day scientists might use the cell's own repair mechanisms to reverse the buildup of errors in the mitochondria and therefore prolong the cell's useful life. Kaluza's paper initially created a sensation. But in the coming years, objections were found to his theory. What was the size of this new 5th dimension? How did it curl up? No answers could be found. For decades Einstein would work on this theory in fits and starts. After he passed away in 1955, the theory was soon forgotten, becoming just a strange footnote to the evolution of physics. Feynman once wrote, "Quantum mechanics describes nature as absurd from the point of view of common sense." And it fully agrees with experiment. So I hope you can accept nature as she is absurd. Einstein wrote, "Quantum mechanics calls for a great deal of respect. But some inner voice tells me that this is not the true Jacob. The theory offers a lot, but it hardly brings us any closer to the old man's secret. For my part, at least, I am convinced that he doesn't throw dice." To impress my PhD students with just how bizarre the quantum theory is, I sometimes ask them to calculate the probability that their atoms will suddenly dissolve and reappear on the other side of a brick wall. Such a teleportation event is impossible under Newtonian physics but is actually allowed under quantum mechanics. The answer, however, is that one would have to wait longer than the lifetime of the universe for this to occur. If you used a computer to graph the Schrödinger wave of your own body, you would find that it very much resembles all the features of your body, except that the graph would be a bit fuzzy, with some of your waves oozing out in all directions. Some of your waves would extend even as far as the distant stars. So there is a very tiny probability that one day you might wake up on a distant planet. 100 years ago, Auguste Comte, a great philosopher, said that humans will never be able to visit the stars, that we will never know what stars are made out of, that's the one thing that science will never ever understand, because they're so far away. And then, just a few years later, scientists took starlight, ran it through a prism, looked at the rainbow coming from the starlight, and said, "Hydrogen." Just a few years after this very rational, very reasonable, very scientific prediction was made, that we'll never know what stars are made of. Beyond work and love, I would add two other ingredients that give meaning to life. First, to fulfill whatever talents we are born with. However blessed we are by fate with different abilities and strengths, we should try to develop them to the fullest, rather than allow them to atrophy and decay. We all know individuals who did not fulfill the promise they showed in childhood. Many of them became haunted by the image of what they might have become. Instead of blaming fate, I think we should accept ourselves as we are and try to fulfill whatever dreams are within our capability. Second, we should try to leave the world a better place than when we entered it. As individuals, we can make a difference, whether it is to probe the secrets of nature, to clean up the environment and work for peace and social justice, or to nurture the inquisitive, vibrant spirit of the young by being a mentor and a guide. It is often stated that of all the theories proposed in this century, the silliest is quantum theory. In fact, some say that the only thing that quantum theory has going for it is that it is unquestionably correct. Some people seek meaning in life through personal gain, through personal relationship, or through personal experiences. However, it seems to me that being blessed with the intellect to divine the ultimate secrets of nature gives meaning enough to life. If at first an idea does not sound absurd, then there is no hope for it. Albert Einstein. The brain weighs only 3 pounds, yet it is the most complex object in the solar system. In some sense, gravity does not exist. What moves the planets and the stars is the distortion of space and time. For those who believe, no explanation is necessary. For those who do not believe, no explanation will suffice. ZBY 2100, our destiny is to become like the gods we once worshipped and feared. But our tools will not be magic wands and potions but the science of computers, nanotechnology, artificial intelligence, biotechnology, and most of all, the quantum theory. Michio Kaku, Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. We have learned more about the brain in the last 15 years than in all prior human history, and the mind, once considered out of reach, is finally assuming center stage. Talent hits a target no one else can hit. Genius hits a target no one else can see. Something as superfluous as play is also an essential feature of our consciousness. If you ask children why they like to play, they will say, because it's fun. But that invites the next question, what is fun? Actually, when children play, they are often trying to reenact complex human interactions in simplified form. Human society is extremely sophisticated, much too involved for the developing brains of young children, so children run simplified simulations of adult society, playing games such as doctor, cops, and robber, and school. Each game is a model that allows children to experiment with a small segment of adult behavior and then run simulations into the future. Similarly, when adults engage in play, such as a game of poker, the brain constantly creates a model of what cards the various players possess, and then projects that model into the future, using previous data about people's personality, ability to bluff, etc. The key to games like chess, cards, and gambling is the ability to simulate the future. Animals, which live largely in the present, are not as good at games as humans are, especially if they involve planning. Infant mammals do engage in a form of play, but this is more for exercise, testing one another, practicing future battles, and establishing the coming social pecking order rather than simulating the future. To understand the difficulty of predicting the next 100 years, we have to appreciate the difficulty that the people of 1900 had in predicting the world of 2000. Recent brain scans have shed light on how the brain simulates the future. These simulations are done mainly in the dorsolateral prefrontal cortex, the CEO of the brain, using memories of the past. On one hand, simulations of the future may produce outcomes that are desirable and pleasurable, in which case the pleasure centers of the brain light up, in the nucleus accumbens and the hypothalamus. On the other hand, these outcomes may also have a downside to them, so the orbitofrontal cortex kicks in to warn us of possible dancers. There is a struggle, then, between different parts of the brain concerning the future, which may have desirable and undesirable outcomes. Ultimately, it is the dorsolateral prefrontal cortex that mediates between these and makes the final decisions. Some neurologists have pointed out that this struggle resembles, in a crude way, the dynamics between Freud's ego, id, and superego. This means that, in some sense, free will is a fake. Decisions are made ahead of time by the brain, without the input of consciousness, and then later the brain tries to cover this up, as it's wont to do, by claiming that the decision was conscious. Dr. Michael Sweeney concludes, Leibott's findings suggested that the brain knows what a person will decide before the person does. The world must reassess not only the idea of movements divided between voluntary and involuntary, but also the very idea of free will. All this seems to indicate that free will, the cornerstone of society, is a fiction, an illusion created by our left brain. So are we masters of our fate, or just pawns in a swindle perpetuated by the brain? It seems that the one characteristic most closely correlated with success in life, which has persisted over the decades, is the ability to delay gratification. If you haven't found something strange during the day, it hasn't been much of a day. John Wheeler. To understand the precise point when the possible becomes the impossible, you have to appreciate and understand the laws of physics. Srinivasa Ramanujan was the strangest man in all of mathematics, probably in the entire history of science. He has been compared to a bursting supernova, illuminating the darkest, most profound corners of mathematics, before being tragically struck down by tuberculosis at the age of 33. Working in total isolation from the main currents of his field, he was able to read 100 years' worth of Western mathematics on his own. The tragedy of his life is that much of his work was wasted rediscovering known mathematics. As Heinz Pagels has said, the challenge to our civilization, which has come from our knowledge of the cosmic energies that fuels the stars, the movement of light and electrons through matter, the intricate molecular order which is the biological basis of life, must be met by the creation of a moral and political order which will accommodate these forces, or we shall be destroyed. It will try our deepest resources of reason and compassion. Intelligence seems to be correlated with the complexity with which we can simulate future events. Early life. Kaku was born in San Jose, California, to second-generation Japanese-American parents. Reflecting on his childhood, he said his grandfather had come to the United States to do the cleanup operation after the 1906 San Francisco earthquake, and his father and mother were both born in California, his father in Palo Alto and his mother in Marysville. Both his parents were interned in the Tule Lake War Relocation Center during World War II, where they met and where his elder brother was born. At the National Science Fair in Albuquerque, New Mexico, he attracted the attention of physicist Edward Teller, who took Kaku as a protege, awarding him the Hertz Engineering Scholarship. Kaku graduated summa cum laude from Harvard University in 1968 and was first in his physics class. Citation needed. He attended the Berkeley Radiation Laboratory at the University of California, Berkeley, receiving a PhD and holding a lectureship at Princeton University in 1972. In 1968, during the Vietnam War, Kaku, who was about to be drafted, joined the United States Army, remaining until 1970. He completed his basic training at Fort Benning, Georgia, and advanced infantry training at Fort Lewis, Washington. However, he was never deployed to Vietnam. 5. Academic career. As part of the research program in 1975 and 1977 at the Department of Physics at the City College of the City University of New York, Kaku worked on research on quantum mechanics 6-7. He was a visitor and member, 1973 and 1990, at the Institute for Advanced Study in Princeton and New York University. He currently holds the Henry Simmet Chair and Professorship in Theoretical Physics at the City College of New York. Between 1970 and 2000, Kaku had papers published in physics journals covering topics such as superstring theory, supergravity, supersymmetry, and hadronic physics. In 1974, Kaku and Professor Keiji Kikuwa of Osaka University co-authored the first papers describing string theory in a field form 10. Kaku is the author of several textbooks on string theory and quantum field theory. Popular science. Kaku is most widely known as a popularizer of Science 11 and physics outreach specialist. He has written books and appeared on many television programs as well as film. He also hosts a weekly radio program. Books. Kaku is the author of various popular science books. Beyond Einstein, The Cosmic Quest for the Theory of the Universe, with Jennifer Thompson, 1987. Hyperspace, A Scientific Odyssey Through Parallel Universes, Time Warps, and the 10th Dimension, 1994. Visions, How Science Will Revolutionize the 21st Century, 1997. Einstein's Cosmos, How Albert Einstein's vision transformed our understanding of space and time, 2004. Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos, 2004. Physics of the Impossible, A Scientific Exploration into the World of Phasors, Force Fields, Teleportation, and Time Travel, 2008. Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100, 2011. The Future of the Mind, The Scientific Quest to Understand, Enhance, and Empower the Mind, 2014. The Future of Humanity, Terraforming Mars, Interstellar Travel, Immortality, and Our Destiny Beyond Earth, 2018, ISBN 978-0525589532. The God Equation, The Quest for a Theory of Everything, 2021, ISBN 978-0385542746. Michio Kaku, Japanese, /Michioku/, born January 24, 1947, is an American theoretical physicist, futurist, and popularizer of science, science communicator. He is a professor of theoretical physics in the City College of New York and CUNY Graduate Center. Kaku is the author of several books about physics and related topics and has made frequent appearances on radio, television, and film. He is also a regular contributor to his own blog, as well as other popular media outlets. His books Physics of the Impossible, 2008, Physics of the Future, 2011, The Future of the Mind, 2014, and The God Equation, The Quest for a Theory of Everything, 2021, became New York Times bestsellers. Kaku has hosted several television specials for the BBC, the Discovery Channel, the History Channel, and the Science Channel. Thank you and be well.